So if you're having some struggle with question 1 and 2 for this assignment, either one, the same thing goes for each one. So let's start with question 1. So Q6, you want to know if Q6 impacts the trust in the influencer recommendation. All right. So if you want to know, does X impact Y, then X is going to be like your input. You're going to put that in to see what its impact is on your output. All right. The output is always kind of like the ending result. So let's say that you have your marketer. You want to know what it impacts revenue. Okay. That's the end result. That's what you're trying to get to. So you're going to try different type of inputs to see what you can do to influence that output. And that's the same thing here. So we want to see, okay, does review reader, does that impact, or can we predict this output, which is going to be trust and influencer recommendation? So that the one thing you're going to want to do is when you're running Stats IQ, you want to make sure that the Q9 has the key symbol on it. All right. So for instance, in this case, this would be my output and this is my input because this has the key symbol right there. All right. So that's step 1. Step 2, here's your p-value. This isn't the p-value for either of these. This is a different situation, but there's your p-value. Just copy and paste the number. Okay. Just the number. Copy and paste it, put it in, and then you should be good to go. And then for this one here, and then your beta is right here in this little equation. It's the number that's being multiplied by your input. Okay, that's your beta. So in this case, it's a negative beta. It's negative 0.696. The slope is going down. So as fake LOL, as that gets higher, you'd predict that Q7 would decrease, it'd get lower. And specifically, you'd say like as fake LOL, as that increased by 1 point, you'd expect Q7 to go down by 0.696. All right. So that's your beta. And here's a little hint here. So you're going to expect these to go up or down based on whether it's a positive or negative beta. Okay. And this is whether it's significant or marginally significant, or if it's a positive beta, it's a positive relationship. If it's a negative beta, it's a negative relationship. And right here, this is just going to be the number for beta. All right. You're just going to repeat beta here. As your input increases by 1 point, you'd expect that Q9 would increase or decrease. And if it's positive beta, it increases. If it's a negative beta, it decreases. And it do so by however many points. And that's your beta there. Okay, so you're using the same number there. I just want to help you kind of think through it and how to apply the beta. But the same advice goes here. This is your input, that's your output. With the beta there, p-value, if it's significant, say so here, or not, right? What the direction is it a positive relationship or negative? Is a beta positive and it increases? If it's negative and it decreases, and then you type your beta again right there. So hope that helps with this one. For questions 3 to 4, you got to start with figuring out what's your input and what's your output. So when you read the sentence, does the extent that the customer knows trends, does that impact the likelihood that they purchase behavior? All right. That if you're wanting to know, does X impact or predict or influence Y, then this is going to be your input and this is going to be your output. All right. So make sure that when you run the analysis, that purchase behavior has the key and not your input. The key goes to your output. All right. So if this is my output, it has a key. If this is my input, it does not have a key. That's just like the default there, right? I'm going to see if fake LOL predicts gender. All right, I'm going to click relate. Let's see what it does. Okay, there's no significant effect in this case, right? But here's my p-value. So when you're looking for p-value, it's there. Your averages, so average for females here, average for male is there. All right. So if this is significant, let's say it was, it looks like, male is slightly higher than female. So if it's significant, then you can go to the next stage. If it's not significant, there's just no relationship between them, right? And it's not a reliable predictor. But if it is significant, then what you're saying is, okay, as my input gets higher, I would it's more likely that it's a male than a female, because male is higher there. Okay, that's a higher number. Again, that's only if this is significant, and this is far from significant. It's 0.925, right? Not significant at all, so we wouldn't count that. That's how you'll go through these ones. Okay, so you put in the averages for each of those, put in the p-value. If it's significant, you put significant or non-significant or marginally. And then as it gets higher, you'd expect the customers that purchase to increase or decrease, right? So you'll have a similar type of output here. So let me show you. I'll take purchase behavior and make this my output, just like the question, and then I'll use fake LOL though as my input. Don't want to give it entirely away, and then I'll click relate. So this is a very similar to this question. We're just using a different input, but same output. So we're looking to see if no trends impacts purchase behavior. In this case, we're looking at fake LOL and purchase behavior. We see no statistically significant relationship. Here's the p-value here, and our averages, okay, between no purchase and purchase. If this was significant, though, we'd see that purchase has a higher average than no purchase. So if this was significant, we say as fake LOL, as our input gets higher, it's more likely that the customer's purchased than not purchased. That's how we would go through and answer that question. So you're putting in the averages, the p-value. You're saying whether it's significant or not, or marginally significant, and then you're writing whether or not it increases the likelihood of purchase as your input gets higher. All right. So if it's higher here for purchase and significant p-values, then as your input gets higher, it's more likely to purchase than not purchase. Okay, so for question 5, what we're looking at here is, again, first thing, you have to establish what your input is and what your output is. So here I'm seeing if Q2 impacts, influences, or predicts something else, right? Anytime a sentence is worded like that, you want to know does your input predict, impact, or influence the output? All right, so that tells us this is the input and this is the output. So if I'm popping over here to run this analysis, repeat purchase is going to be my output. So I'm going to go to repeat purchase. I'm going to make sure that has the key, and then I'm going to select Q9 instead of Q2, just so we're not getting exactly the same answers. I want you to work through this as well, for sure. Okay, I'm seeing a statistically significant relationship. I'm looking here. Here's my p-value. But the question does say, let's filter out NA. So I'm going to filter out NA. I'm going to go to, for this analysis, this filters part right here. Now I'm going to click Add Condition Group. I'm going to go here and do repeat purchases and say it does not equal NA. Then I'll filter that out. And so NA is not here. yeah, here's my p-value. That's the p-value that I would enter here. It's going to look different for you because it's a different input there, right? Here are my averages. So I see it looks like frequent buyer is higher, then it comes to occasional buyer, and then it goes to first-time buyer. But again, since we have more than 2 categories, this p-value doesn't mean that your input predicts the differences between all of these. A 3.9 and a 3.96, that's pretty similar. I doubt that that's significant. So let's go to the pairwise comparison table. This gives us the p-value between frequent buyer and occasional buyer. The second one gives us the p-value between first-time buyer and frequent buyer. And this last one gives us a p-value between first-time buyer and occasional buyer. Obviously, these two are the top two are the significant ones, not this last one. So just as I said, 3.9 and a 3.96, those are not statistically significant, all right? But frequent buyer is higher, statistically higher than first-time buyer, and frequent buyer is also statistically higher than occasional buyer, all right? So what we can say from this is as our input goes up, it's more likely that they are a frequent buyer, the customer's a frequent buyer, than a first-time buyer. It's also more likely that they're a frequent buyer than an occasional buyer. But we wouldn't say that as your input gets higher, it's more likely to be occasional buyer than a first-time buyer because the differences between those two groups are not statistically significant. There's a p-value of 0.9, so there's a 90% likelihood that they're due to chance. We're not gonna go on those. Okay, so that's how you'll do logistic regression when you have more than 2 categories, and that should definitely set you up to answer here. You're just putting the averages for the 3 of those, the p-value. As Q2 goes up, are they more likely to be frequent buyer or occasional buyer? So compared to an occasional buyer, so you could say less or more. If frequent has a higher average than occasional, then you're going to say more. And also if the p-value is significant, right? Here, if frequent buyer is higher than first-time buyer, you're going to say more. Here, if it's more or less, you're going to say more, right? But if any of these p-values are not significant between these, then you're going to say like just as. All right. So that's how you'll do that one. Be sure to reach out to me if you have any questions.